Afternoon, everyone. I welcome you all and our next speaker, Dr. Srinivas Padmanabhuni, for this post-lunch session on the fifth day of this faculty development program on artificial intelligence. So, in this session, Dr. Srinivas will be briefing us on the topic of AI in finance technology. So, before we start the session, first I would like to request my colleague, Ms. Sangeeta Kumar ma'am, to give a brief introduction of our next speaker, and then we'll start the session. Ma'am, you can have the stage.
Thank you, sir. Good afternoon, everyone. So, it is my great honor to introduce and welcome our eminent speaker, Dr. Srinivas Padmanabhuni. Dr. Srinivas is a co-founder and CTO of CityMandi, that is an AI-enabled smart. I Hello. Am I audible?
Yes, ma'am, you're audible.
Hello.
Yes, ma'am, you're audible.
Am I? Dr. Srinivas is a co-founder and CTO of CityMandi, that is an AI-enabled smart business-to-business startup in agriculture technology domain. He is also acting as AI advisor at Marks AI and visiting professor at IIIT Lucknow. He is also associated with Trah Technologies as a chief mentor. He has been president of ACM India from 2014 to 2016. He had completed his PhD from University of Alberta, Canada, with specialization in AI technology, and MTech from IIT Bombay and BTech from IIT Kanpur. He has to his credit 7 patents, 1 book by Wheeler, 100 plus international publication, 400 invited talk across 8 countries, and 4 plus startups related to AI and associated areas. He has been awarded with the Eminent Engineer Award by Institute of Engineers India. Now I welcome Dr. Srinivas. Sir, please, sir.
Is my presentation visible?
Yes,
And
sir.
I'm audible?
Yes, sir. It is visible and clearly audible.
Okay. Welcome to this, I think, last session of your FDP. So I'll try to keep it as interesting as possible. So the goal of exploration of this technology, which is AI, in a business context, which is finance technology. So what I'm going to do is I'm going to talk three things. First, what exactly is the role AI is playing in business? Primarily, what is the reason why AI is so important in the business context? Then we look at what exactly is meant by AI ML. It may be repetition for some of you, but I want to put it in the context so that you can get into a detailed analysis of when we go into actual applications in the finance domain, how they translate into some fundamental problems in AI. Now, at the start, I want to start with a big bang, saying that today we are in the midst of a massive digital business transformation. I don't think anybody will disagree. The very fact that we are having this conference where people across the country are sitting in their houses, attending it in a virtual manner, as opposed to imagine all of us traveling to some place, specifically at a location, hiring a rental room, going through a projector, etc. But the same thing we're doing in a digital manner. What else can be the proof of this? Same way, you look at the hundreds of billions of dollars of industry like IT, information technology. Companies are working with people across the globe sitting in their rooms and contributing to projects. Governments are being run by representatives sitting at different homes and working. Judiciary is carrying out judgments and sessions by lawyers and judges sitting in their houses. So the kind of digital disruption we're talking about is unimaginable. Of course, majority is about a forced due to corona, but the point really accelerated the whole digital disruption. And the point I wanted to mention is in terms of businesses also, we see there is a new normal in terms of disruption in a real sense. When I talk about disruption, it is important to understand that disruption can be so lethal that some companies can just close because they have not followed the digital trend. Then we saw that how some of the conventional veteran companies just had to fold because they could not transform to the digital wave. Like Blockbuster, which could not adapt to streaming video. Kodak, which could not adapt to digital photography. Borders, which could not adapt to e-commerce. So what we have winners who adopted digital. Pioneering the video services. Amazon pioneered e-commerce. Uber pioneered ride sharing with a digital manner. And when we talk about the digital technology as transforming businesses, we also need to understand that the disruption is happening by a bunch of technologies. It could be IoT, it could be cloud, it could be social, it could be mobile. But I think the primary among them is that of bringing data to business transformation and how data-driven insight generation has become a common practice across all business domains. So today we have scenarios of AI doing a lot of work which was earlier getting done by human effort. See, for example, AI diagnosis diabetic retinopathy replacing ophthalmologist. AI billing a shopper in an automated checkout store without a checkout. AI driving a car, autonomous driving replacing a driver. AI saving a life, calling an ambulance directly. So in all of this, we actually got to understand that we really have to look at it from the perspective of how the disruption we're seeing in the business is triggered with AI as an accelerator of the digital disruption. So that is very to understand why we need to study AI, why we need to understand the implications of AI on business and how we carry out our business. So while we talk about AI, that's fine. But what exactly is this whole notion of AI? AI is about intelligence exhibited by machines. It's about the exhibition of capabilities of humans which display intelligence. When I say machine, it can be a software machine like a bot, or it could be a hardware like a very smart medical device, or a robot which has embedded intelligence in them. So what exactly is this aspect of human intelligence which is displayed by these intelligent agents? The overall process of mimicking human intelligence is about sensing, processing, and responding. When I say sensing, it's about emulating human senses for gathering data. For example, there is a computer vision system of AI which is seeing by looking at an image or video and emulating human eye. Similarly, an Alexa-like hardware is listening to what you're saying, digesting it, and it's speaking out like a human. Similarly, when a Google search is seeing what you're typing, it's understanding the text, analyzing it, and getting you back a text, which is basically the response of processing that text. So, important component you need to understand is that in all of this, we're trying to emulate standard human senses of for data acquisition. Then processing is where you try to analyze the data for insights, and that's exactly where machine learning starts to come in. What's exactly machine learning? It is the part where you are processing the ingested data for patterns. So once you analyze those patterns, then you go back and see if there is some response to be sent. But one thing, caveat, which is very important today in the context of AI is that we do not yet have a emulation of the sense, smell, or taste. Okay, so or even touch. Though touch is slowly getting emulated with lots of interesting sensors, etc. But it will be some time before we see these senses coming into the domain of AI. So primarily, if you look at AI, it's about any kind of data. But specifically, if you look at emulating eyes, it's about computer vision. If it's about emulating the art of speech, it's about speech recognition. If it's about the art of text, it's about natural language processing. So the applications and capabilities of AI systems are further improved if we look at application using the concepts of natural language processing, computer vision, and speech processing, which enables us to mimic as close to human senses as possible. So as we saw, what is human intelligence? It's the process of sensing, getting data, acquiring data, processing and analyzing the data for patterns, and based on that, take some action. See, in any example, whether you talk about Alexa bot, or you talk about driverless car, or you talk about Google search, all of them are examples of AI applications which are sensing data, processing enough kind of data, and making sure that it is a really intelligent task of extracting patterns from data, which is what we'll later call as machine learning. So then now the question is, all of this is great, but AI has been there for last 50 years, more than 50 years. In fact, 1956 is when we started working on AI as a core concept in computing. So why now? The forces at play are basically big and affordable compute available to everyone. You really have at your doorstep, you can access using cloud any infrastructure which you want. It could even be NVIDIA large number of processors contained server at a reasonable affordable rate. Low cost of sensors, which makes it possible to provide internet of everything, thereby generating lots and lots of data. And that's causing explosion of new data pools, which provide raw data for AI. AI is all about data hungry, right? Then we also see the prevalence of open innovation. Open innovation talks about where you take a specific new innovation that comes up, it's immediately propagated in the community. It's not like people want to keep their innovations within their organization. A lot of open innovation happening. Latest algorithms are coming up and then donated in the open source community. Lots of further innovation takes place on top of it by developing applications, use cases, etc. So the whole innovation ecosystem is working round the clock on how it is basically talking about making the power of generating newer solutions and products based on innovation, faster and cheaper. So these are the forces at play, which is basically bringing AI to the forefront to be able to carry out business transformation and thereupon a big digital disruption. So when we talk about digital disruption with AI, what exactly are the components of AI which enable it to do the whole cycle of sensing, processing, and responding? So if you see, AI by itself is a conglomeration of a set of underlying concepts. By itself, AI is not like there is an overarching concept called AI. It's all about a conceptual set of grouping of related technologies which come together to mimic human intelligence. So what are those related technologies? So the core of today's intelligence systems or AI-enabled systems are the technology called machine learning, which is basically a technique by which you take lots of raw data, crunch it, and extract patterns from there. So that's what is machine learning. It's about extracting patterns from raw data. When the raw data happens to be images, videos, like what a human eye would see, it is computer vision. If it is NLP and text mining, which is basically text as input and processing text for patterns, it becomes NLP. Then if you look at speech or audio as the input on which you want to extract insights, it becomes speech processing, including speech understanding, speech recognition, etc. But at the same time, while these are the core technologies which enable the concept of pattern extraction from data, but AI is not just machine learning. There is far more concepts in AI beyond machine learning. So when you see a IBM Deep Blue program playing and winning against Kasparov, or when you see an AI program which is going and beating world checkers champion like Shinu, there are lots of AI technologies at play which are not necessarily about pattern finding. So there's a lot of AI components which are beyond machine learning. For example, if you look at the whole gameplay, it's all about understanding the search and how to traverse the search space in an optimal manner while making sure that you're satisfying the constraints. What are constraints? It's like when you are in a board position in chess, say, it's not like the queen can go anywhere. It has only specific moves it can make. Same way a horse can only make specific moves. Those are the constraints. The search is the overall search space. The different moves you can make. After that, the next moves you make. That's the whole search space. So what you need to look at is how do you optimize the search space by appropriate planning and making sure that you're traversing the space in an optimal manner. And in fact, this particular concept of constraint search and optimization and planning is also basis of how the machine learning algorithms are implemented. Every machine learning algorithm internally actually uses the concept of a complex search guided by the right optimization criteria subject to proper constraints. Then in addition to games and search, we also have the concept of logical deductive expert systems. This is where AI was successful in its first wave in 80s. Lots of AI expert systems became popular in business for solving problems like tax computation, legal processing, etc., where humans and experts would write different logical rules in a domain, and that system would be working like an intelligent system given the data to tell you what decision to take. And that's exactly what was used inside IBM Watson computer. Beat human quiz champion, which is basically the champion of the program known as Jeopardy. So there was a lot of logical deductive component where given existing facts, you can derive new facts using the concept of deductivism. And that's not machine learning. That's purely the opposite of machine learning. Machine learning actually is inductive reasoning, where you take a lot of raw data and you generalize and compute logical patterns from it. Whereas in deductive reasoning from a raw data and a set of logical rules and patterns, you try to derive new facts or new data. That's why it's opposite of inductive reasoning. So you see, AI is not just about using the concept of machine learning. It's about a conglomeration of several technologies. It's about machine learning applied with computer vision, NLP, or speech processing. Then it's about applying a search guided by optimization and constraints being enforced. Then it's about applying logical reasoning to underlying systems. So in earlier days, 80s and 90s, there were a lot of AI applications built in the banking and finance domain using systems. So when you have expert systems for building banking systems, it used to be like, okay, if I have some problem, I have an expert system and I'll tell this is my problem. The expert system would diagnose and find out, okay, this is a possible root cause, and tell you back, okay, this is a possible root cause why your system is not working. So we see AI is not a standalone thing. It's a combination of several technologies. Now comes the interesting slide. I spent some time on it. People have been trying different keywords. People have talked about data science. People have talked about machine learning. People have talked about deep learning. People have talked about AI. So let me tell you, the Venn diagram looks like this. AI and data science intersect. In that intersection lies ML, and inside ML lies DL. But AI has possibilities outside data science also. Data science has possibilities outside AI ML. So let's look at AI itself, right? We saw AI is overall lots and lots of technologies like this. So if you see, AI can also involve things like deductive reasoning, search, planning, which need not be anything about data science. And data science can be different kinds of analytics. Data science and analytics are used synonymously. So in analytics, we usually have several shallow analytics like descriptive analytics or exploratory visualization, which does not need complex predictive models like machine learning. But when you do predictive analytics, it is the intersection of data science and AI, where primarily it is about machine learning. And within machine learning, there is a subset which is called deep learning, which is primarily focused on making sure that the NLP or the computer vision or the speech processing systems work seamlessly with machine learning, with automatic feature extraction rather than manual featuring. So in all, if you see, this is a really conceptual slide, which all of you should understand, because a lot of jargon we hear everywhere, talking about data science, talking about ML, talking about DL, talking about AI. But this is the reality. So let's look at what exactly is the primary technology in AI, which is enabling us to create these modern applications. So if you look at the modern applications, which are primarily getting to be the mainstream of all the AI, that is nothing but machine learning. So what exactly is machine learning? Machine learning is a facet of AI where you take raw data and automatically infer patterns from the data, automatically learn patterns from the data. So what exactly is machine learning doing? In machine learning, you're trying to extract patterns in form of a model from data. It's quite different from programming. Why is it different from programming? Because in programming, logic is controlled by the programmer. But in machine learning, humans have no control over the logic or the program or the model that is generated. In machine learning, it is data in, program out. So logic is hidden inside the data, which is extracted in the form of the model. So the only way the model can be changed is by changing the data that is fed to it. We cannot change the model any other way. So there's no actual access to the model, like if you want to change if then else clause or something in terms of debugging. So debugging in machine learning is all about debugging by changing the data and seeing analysis of behavior with respect to that. So there are several categories of ML processes as we speak, or applications of AI in data science. So what are the prominent kinds of processes? Then we'll come to very specific categorization, etc. But to start with, let us look at a scenario where we have to find groups of people with similar behavior. That's known as clustering. On the other hand, if suppose you have a group of people and you want to put them into 3 or 4 fixed buckets, like are they high credit worthy, no low credit worthy, or normal credit. 3 categories. That's a classifier. Let's say you want to use your historical data to predict something for the future, some value. Like say, for example, what will be the temperature opening for the day tomorrow. So that is what we call as a prediction. There are other technical terms called regression for this, but we'll come to a bit later. Then we talk about text miner, which is basically taking a lot of text data, and from the text data, you want to extract patterns like word clouds, understanding what is the dominant concept being talked about. And that becomes a primary concept known as text miner. And when I talk about text miner, it's about intelligent concepts, intelligent patterns extracted out of text data. Next is network analyzer. What exactly is network analyzer? This is very important in today's terms, especially in the world of COVID. If you look at what the law enforcement authorities do or the health authorities, when they find a COVID affected person, they do contact tracing. The contact tracing is about taking your immediate people whom you have been in touch with, then who they have been in touch with, form a next graph. So you form a full network, and based on that, you try to retrieve people whom you have to warn. So there are several examples of such network analysis in our daily life. For example, if you look at Facebook, it's a social graph. It's about you are connected to your friends. They are connected to their friends. They are connected to their friends. Like that, you form a full social graph. It's a billion by billion edge. So you can form interesting patterns from networks of nodes, where each node is a person. So what kind of patterns could be used there? Like you can find influencers in your social network. Maybe as a marketing company, if you're a finance company, you're looking to market and you want to target the influencers in the social circle so that your product gets sold better. So you can use the concept of network analysis to find out influencers in the social network and try to maybe financially lucrative model for them where they endorse your product so that it is known to many people because many people are connected to them. It's a highly dense network around those influencers. Now, we also look at frequent sequence pattern mining. When I say frequent sequence pattern mining, it's about finding items which occur together, items which are obtained as co-occurring items. Where do you find that? When you're shopping online, I'm sure many of you have seen people who've bought this also bought this. That's a typical sequence analysis. There two items always occur together in a shopping basket. That's what Amazon and Flipkart use to suggest items to you when you buy something. Then video analytics. Video analytics is about look at the videos and see if you can detect patterns. For example, if you have a video which is surveillance video, from the surveillance video, you want to identify a specific example of any intruder, because that's not a known face among your database. So what is that? That's a video analytics where you're trying to identify key people who are not previously known. Then we have augmented bots, industrial bots, chat bots, which are support bots or consumer service bots, which take into account the customer service jobs and do the task of what a typical customer service representative would do. So what these bots would do, they would listen to your customer, understand their question, and get you back the required output. So it is important that the concepts related to applying ML in daily life is looked at through this process. What kind of process are we talking about? We'll again, of course, come back to one specific way of looking at this process from different categories of ML. That's what we're doing here. Rough idea of some of the common things we try to do. This is not just enough. There are many, many, many patterns. I can tell you, I can go on giving you lists of things we can do. Only some I have listed here. But all the typical ML process you can think of as doing broadly three things. The first one is what we call as supervised machine learning. And in supervised machine learning, we're primarily looking at scenarios where we have an output variable and a bunch of input data. I'm saying input data. It may be variables or it may be input image or it could be image text also. So it need not be like we only have set of input columns. It can be input columns or input data like an image. But the important part of supervised machine learning is that we have a definite output variable, so it makes it easier to find patterns relating the input data to the output data. The next one is what we call as unsupervised machine learning, where we primarily look at patterns in data. There's no concept of any kind of output variable. We just take raw data, look at the patterns in that. Then we look at reinforcement learning. What exactly is reinforcement learning? We look at reinforcement learning as a kind of learning where we start with zero background data. We start with zero background data. So what we do is we try to find out from zero background data, we will start the process of the system learning by making it run through several iterations. And when it runs through all the stages from start to finish in several iterations, you will find that reinforcement learning is really has learned the underlying patterns which are enabling it to take optimal step at every point and becomes really smart. So reinforcement learning is hard, but at the same time, it is very, very clearly a tough nut to crack. So what I'm going to do is I'm going to just start explaining each of them one by one before we go into actual applications in the banking domain. I'll start with reinforcement learning explained in a video here. You look at this video, you'll observe that learning from experience can be very, very powerful. Please observe this.
Good grammar and spelling are important, but if you want to write essays that inspire,
Please note this. Where we're learning from experience. So in reinforcement learning, we usually have no background starting point, but we let the system run for several runs from start to finish. And at each state, you have a reward and a punishment depending on the move. And the idea is you ultimately become a very smart program which you have learned from experience. Now coming to the first one, which is supervised machine learning. We said supervised machine learning is all about making sure that you have an output variable and you have input data. Input data could be an image or it could be a set of columns. So what happens in supervised machine learning is that we take the output variable and find the relationship between the output variable and the input data. So there are two kinds of supervised machine learning. One where the output is discrete or categorical, means it has only few values. That is called classification. And each of the categories is called as a class. So what you do is you try to classify the data into one or more categories which you know beforehand. An example, suppose based on the customer data, you want to classify the customer into, is he going to be a high defaulter or medium defaulter or low defaulter? Or look at your emails and break it into Is it a spam mail or is it not a spam mail? Then we call it a classification type of problem in the supervised context. But when we talk about output variable being continuous, that is what we call as a regression. Making a curve fitting the output value prediction possible from input variables. Like you want to predict stock value of a certain script for opening tomorrow based on historical analysis of data, whether any news stock, etc. So when you're predicting output value for a particular stock, you're actually doing a regression. And then when we talk about any of the supervised machine learning algorithms, depending upon the output, whether it is discrete or it is continuous, we try to look at it as a classification or a regression. Classification means discrete, categorical variables output, few classes, whereas regression means predicting a continuous output value from input values. So supervised in one sense is probably the easiest among all the types of machine learning because you have output variable and you have input variable. So because of this, what we do is we typically use the concept of training and testing split of the data. We split the data into two parts. One is training data randomly, say 80%, and 20% keep aside. You create your classifier or regression model, and then you test how good it is by applying it on the output input. So best applying it on the test data. So when you apply it on the test data, you get some value and you can compare that with the expected class or the value and see how good it is. If it is regression, you'll see how much of the error. If you see classification, you'll see how much percentage of test data it's predicting correct class. That's called accuracy. So the beauty of supervised mechanism is that if you have input data and output data, whether categorical or continuous, you have much more robust ways of measuring the application of ML in that domain. So when you look at actual applications in finance technology, we'll see a lot of applications as we go along of supervised machine learning, where you're using regression or maybe using classification. And similar to supervised, where you have historical data, but in unsupervised machine learning, we don't have any idea of output variable. We only have something called as data, input data. That's it. And then we are asked to find some pattern. And that is exactly what we do in unsupervised machine learning. So what do you do when you have only data? You extract patterns. What are the patterns you extract? You extract patterns like clusters. What is clusters? If you look at the previous slide, we talked about finding groups of data with similar behavior. That's exactly what is clustering. So clustering is nothing but identifying groups of data with similar behavior. Then association rule mining is about identifying patterns in the data, which is giving you rules of the form. Customers who bought this also bought this. So let's do a simple session. I'll just go through a small shopping session. Let's say I go to Amazon.in and I just type for some, let's say I go and buy a Harry Potter book. I buy this, or I buy a Tintin, something like that. And immediately you'll see below, customers who bought this also bought this. What exactly is this? This is a classic example of association rule mining, also known as market basket analysis. When I say association rule mining, the idea is that you try to come up with rules of this form where customers who bought also bought this. So A implies B. If you bought A, I will recommend B. So what is this? This is a kind of extraction of items which have been occurring together in lots of shopping baskets. And that's what people try to do. They try to find sequence of items or collection of items which have been bought together and try to form rules there. And it's purely from the raw data of transactions which people have been doing. There's no specific label or anything. It's purely unsupervised machine learning. Then next one is very important, is the concept of anomaly detection. Anomaly detection is about, suppose you have data in which about 99% of the data is all looking similar. But there is one data item which looks very different from the others. Let's say we have a group of 100 shirts which you are trying to buy. All of them are some shade of, let's say, blue. But suddenly we see one sample which is a pink shirt, which is out of this sample. That pink shirt really stands out in contrast to the other normal data, right? So abnormal in a large collection of data is what our goal is. So what we do is we try to detect such anomalies. Where are these useful? These are useful if you want to detect fraud. You have normal transactions, but suddenly you see one unusual transaction. You usually shop for something like, say, normally you do 1,000 rupees or something. But suddenly you get a request that I need 1 lakh transaction on your credit card. So that is something which is anomalous. Credit card may want to call you and find out if you are really doing the transaction. So what is that? It's an anomalous data in an otherwise collection of largely normal data. So that's a normal data out of which you're extracting some anomalous data. So that's why unsupervised machine. Then we have collaborative filtering, which is a very simple extension to the concept of association rule mining. In association rule mining, you try to find groups of items which are occurring together. But there's nothing about which one you like more or what is the bonding between the item and item. Nothing you do. But suppose I say that I look at buying one of the possible 10 books. Which one should be recommended to me? I have this question. Then what you do is you look at your past 50, 60 books which you have bought and you try to find out the item which or the book which is most similar to your taste of past books. You will try to recommend that. So there's a notion of similar. So what collaborative filtering does is based on item similarity, it will try to recommend an item. There's no concept of only occurring together. It's about more important data, like what is the similarity of the items. Similarly, you can have another session where you say that I want to go to a movie or I want to watch a movie on Netflix, but I'm not sure out of the 5 or 6 new arrivals which one I should try. What I will do is I will poll 10 of my closest friends and ask them what they typically would like. And based on what my friends like, I will be recommended out of the 10, the one which majority of my friends like. And that is called user-based collaborative filtering. So user-based collaborative filtering is a classic example of collaborative filtering where you're trying to find tastes of similar users. Whereas item-based collaborative filtering looks at similarity of items to recommend what item to be given to you. And as I said, in terms of the kind of patterns in unsupervised analysis, there are several such analysis of patterns. Like network analysis. What is network analysis? You see here, network analyzer. What is it? It's basically talking about what is the set of influencers in your network, or who are the set of people whom you have been in touch with or they have been in touch with. This is some level of depth. So these are the typical network analysis problems which are looking at the typical graph data, and from that graph data they mine. It's also called as graph mining as one kind of unsupervised machine. That's not all. So because we don't have the notion of any output variable, any pattern which you extract from data can become unsupervised machine learning. Like concept mining. Let's say we're talking about we have large text, and in that text, we try to look at what are the different concepts being talked about. That becomes another unsupervised machine learning. So we said here, right? You see here text, lots of concepts in the text. We find out by word cloud what is the dominant concept being talked about. So unsupervised machine learning can be different kind of patterns depending on the context. So you need to understand that when we talk about any of the application of either of the three, reinforcement learning, unsupervised machine learning, or supervised machine learning, supervised is probably the easiest because you have output variable. You have to find the relation between output and input. So you either do a regressor or a classifier. Whereas reinforcement learning is even harder because you don't have any historical data. You're just keeping on learning from experience. Then you talk about unsupervised, which is all about different patterns. Then within unsupervised, a lot of times you may have to deal with images or audio or text. And in that case, there is a specific phenomenon called as deep learning, which is again a type of machine learning. But what it does is it extracts features from these unstructured data so that you can directly do a classification or a regression. For example, if you're given a bunch of images related to cancer, you label them. This contains cancer, this does not contain cancer. So the way automated feature extraction works with deep learning is that you can directly give image as the data to the classifier and give hundreds of them, and then when you give a new X-ray, it automatically cancer or not. So what deep learning based unsupervised feature extraction does is that it extracts these features automatically without any input variables being fed into the data. If you don't have that, what do you do conventionally if you're doing machine learning? So if you see what used to happen in the real world is that if you had to really do some interesting output for if you see the way currently, if you use conventional machine learning on images, you would have to create artificially some variables which are representing the image without the image directly being fed. So you will have something like what the nuclei, what the chromatin, what is the nucleoli, what's the mitosis, all that. Then it's a classification because it says output 2 is benign, 4 for malignant. But the input variables are standard columns which have to be given as input, which are substitute for the data which is contained in the image. So here also you're doing classification, but with indirect data, which are features which you have defined out of the image and passed as data for classification. Whereas in case of deep learning, you can directly take the cancer X-rays, pass image as a data for your classification. And that is the beauty of deep learning based feature extraction, which allows you to extract features from unstructured data. Same way if you do extraction of sentiments from tweets. If you have to really do that, you have to first do deep learning based feature extraction from the text data in the tweets and then pass it to a sentiment classifier. I have 3 sentiments to negative neutrals. So you'll create a classifier on the features extracted from the raw data by applying deep learning on the text data. So what I want to tell you is unsupervised feature extraction with deep learning is the foundation of many of today's applications in the world of AI because they are enabling audio and image, text to be first-class citizens just like a normal Excel or a tabular data would do, which is what machine learning would normally understand. So that's why deep learning is considered as a great solution in the world of AI, which has brought several industry applications and which has brought the world of AI closer to business. And that is why we are able to see applications like chatbots, applications like sentiment analyzers, applications like automated face recognition based ATMs, or you're able to see voice recognition based ATMs. Several such applications are possible because of the availability of deep learning to make the audio, video, image, and text as first class citizens, just like normal tabular data. So, with that, I'll go into now how we see different kinds of products and services and solutions which are there in our daily life, where we're seeing application of one or many of these techniques which we studied till now. Let us look at face recognition. Today, face recognition is considered as a very basic AI artifact developed out of deep learning, which helps in lots of applications. It could be for a recognition in an ATM, or it could be for a security system for entering a bank premises, or it could be for a video KYC. Imagine KYC where you can do digital KYC without ever going to visit a bank. So you need to understand that this availability of face recognition as a service because of deep learning models is a huge enabler in terms of expediting several financial services. The next category is also very, very important: virtual assistants. Virtual assistants is about making sure that the customer service function which you're doing, till about 3-4 years back, customer service function was fragmented. There used to be a call center, there used to be a web-based form, and there used to be email support, all of that very fragmented. But now all companies are trying to merge all of them into one integrated content, which is virtual assistant. And once you have a virtual assistant, which is the basic framework of developing what we call as the concept of AI-enabled chat, which is what becomes the crucial enabler for you. So this again can be in two forms. One could be based on text, another could be based on an app on top of device like Siri or Alexa. So you can either have a voice-based virtual assistant, or you can have a simple text-based virtual assistant. Today, almost every bank out there, every financial service organization out there have deployed bots at the front end for customer service. But customer service is just one category of application. Today, there is another category of applications of virtual assistants, which is in the support. Support bots, where people are coming and trying to resolve issues or support a product when they want some help in customizing the product or filing a complaint on a product, etc. So here again, as I said, it is important to understand that the virtual assistant can be voice bots or it can be text chatbots. Both are equally applicable and getting popular. In fact, a lot of places, voice chatbots are getting very popular now. Especially in a scenario where you're developing these things in a customer environment where customers are quite illiterate. They may not be able to write. In that case, voice-based bots, or called voice bots, are getting to be very fundamental. Online fraud detection, next big use case. Think about it. I told you example of credit card. A lot of transactions of typical thousands. But suddenly you see one anomalous transaction, which is about 1 lakh being charged on your card. So the company may want to detect such kind of anomaly and say, no, you don't want to be allowing this. They call you and say, are you genuinely doing it or not? So fraud detection of different kinds. It could be like in a typical, let's say you're talking about the behavior of shoppers in a site where they normally buy so and so, but suddenly you see that they have amassed 10 times the normal basket size. So suddenly a flag gets raised that user, he's a genuine guy or somebody has stolen his credentials. So you want to look at online fraud detection, or fraud detection in general is a huge case of application of machine learning. Traffic prediction by looking at typical different ways by which you try to estimate time taken by you to reach your office, for example. Start of the time, what weekday it is, what is the traffic prediction going to be heavy or not. You may want to predict how much time it will take for you to go there. It's like a regression. Product recommendation, as I said, right? This is a great opportunity for using unsupervised collaborative filtering or unsupervised market basket analysis, come association rule mining for banking and financial services companies to upsell and cross-sell. Not only that, you will be surprised in larger consulting companies which offer the portfolio management for HNIs and their customers. They actually try to bundle products together for maximum revenue by using machine learning based recommended combinations of products. So there's several combinations where you can see such kind of usage of machine learning in product recommendations. Video surveillance, as I already told you, this is one where we're talking about monitoring premises of banks, etc. becomes a huge. So these are just some horizontal applications powered by different kinds of machine learning algorithms, but horizontal applications applicable across financial services or banks. Then if you look at further such horizontal examples, we see object detection in cameras, detecting individual objects. Video analytics, like identifying intruders versus normal. Image segmentation, where suppose you don't want to just say this object is present, but you want to count number of people of types, number of cars. Then you have to go to the next level where you do image segmentation. Semantic text is taking text analysis to next level where similar words, similar meaning words also are captured, not just by frequency, but by looking at similarity of the meaning, etc. Weather forecasting is typical regression problem. Speech recognition, I already told you, it's about unsupervised feature extraction of the right features from speech inputs and passing it on to either a voice bot or maybe a command which it understands and comes back with a response. So let's look at more examples. While these were horizontal examples which you can go and try applying in BFSI, let us do a pointed example of AI applications. Some of it I already repeated, but I can tell you more and more examples. Let us say we have different financial applications like trading, credit, customer relationship management, risk management. In all of these domains, we can use any of these combinations of machine learning to apply. Channel migration analysis. This is about making, this is just one example. It's not about migration, but also looking at cross-channel analytics. If you are banking across different channels, branch, online, then you have Alexa banking, then you have chat banking, then you have SMS banking. You have different kinds of ways channels open up to customers. So you want to do analytics of the data, which channel is more popular, which channel is giving more support requests. Or you want to carry out synonymous analysis of what channel is currently more popular among customers. Automated trading. This is again a very huge concept that is happening, especially in the larger scheme of things in Wall Street and other trading engines across the world, where there are bots which are carrying out micro trades. They have been advised and some filters and some basic criteria given by humans, but they take a call on what to bet on, where to trade on. So automated trading is going to be a mainstream example as we go along further and further in our lives. Customer acquisition model. This is exactly what I was telling you, right? If you see a person who, in collaborative filtering, if you see a person who is a friend of yours, you're already a customer. So using collaborative filtering, you can suggest him to recommend your friend based on upselling and cross-selling opportunities. Fraud detection, I already examined. Instrument predictors. These are basically talking about potential prediction of stock or potential prediction of some financial script or some mutual fund. Is there a potential for it to go up or go down? Can we have a risk indicator? Money transmission database model. This is again looking at data of all the different, transactions that are happening between online, offline. Do them kind of analytics on the different transactions. Credit risk management. Looking at past history of consumers, whether they have actually carry out a lot of online transactions or whether they have defaulted. Look at all that transactions and what kind of risk profile you're carrying for that particular person. Based on that, you determine probability of default modeling. And once you have that, you try to find out whether you should give a limit of 1 lakh or you should give a limit of 10 lakhs to the particular person. So in all of this, what you're trying to see is there is data at the core, and using the data, you're trying to use insights and then carry out something automation or carry out analytics to do your task better. Let's look at more examples. There are lots of examples of AI-based solutions for financial services, from enhancing the cybersecurity. Like Data Robot has automated predictive modeling, which can be used in several scenarios, including there is a cyber threat detection and hunting solution. Sorry, I had this wrong. So what Data Robot does is it automates predictive modeling for several scenarios. It could be for stock prediction, it could be for product configuration model, it could be for credit default modeling, etc. Then we have cybersecurity solution, which is very useful for financial domain, especially like Vectra, Darktrace. What they do is they use cyber AI-based solutions based on analysis of past malware and different attack patterns, and they warn you of potential threat even before an actual attack happens, and thereby prevent disasters from happening. Then there is of what options you have to save your money. This is basically guided by past historic data of where some of the investment vehicles have been able to give better returns, or where we got a possibility of generating a lot of additional money compared to other investment opportunities. So what these guys do is they create something like an expert system based on your risk profile, what kind of investment you want to do, what is your probable likely instrument, and suggest these kind of systems. Then underwriting in insurance is very, very crucial. Underwriters are the ones who decide on how much should be your premium. So today, lots of financial services companies like, let's say, Just Finance or even our homegrown Bajaj Finance, they're using AI and machine learning to do automated underwriting rather than depending on a human. So how do they get the data? They get the data by looking at past credit behavior of people, their salary level, what kind of profession they are, what kind of equipment they're buying. And based on that, they also they defaulted, have they not defaulted, have they paid proper everything. And based on all of that, and then look at CIBIL score. Based on that, they find if they're reasonably straightforward scenarios, they can even do a straight-through processing of the system without even an underwriter actually coming into the place. So they have AI-enabled underwriting possibilities where You don't have to worry about a human to be always present and always give the final answer about what should be my premium or what should be the application. Then also look at the kind of personal finance where you're trying to look at some intelligent software which is going to monitor where you are spending, where you are overspending, where you're spending less. So there are apps which are powered by intelligence inside them, which keep track of your finances and give intelligent suggestions. Then there are companies like Kasisto, then even Bangalore-based company like Senseforth.ai, which do conversational AI platforms for finance industry, whether it is bank or insurance companies. They provide custom chatbots or voice bots for financial services industry. For example, I don't know if any of you have HDFC accounts. If HDFC account bot called EVA was developed by Senseforth Technologies, which is an AI company which develops custom bots. So today, almost every bank, every financial services company, every insurance company is actually looking at generating customer service front ends using AI-based chatbots, which use a combination of ML and NLP technologies. Both are required to make a typical chatbot. More examples. Let's say we have a financial assistant here called Abe. So what Abe does is it creates a smart financial chatbot which helps you in your financial decisions. Then you look at Zipari. It's a first and only consumer experience platform specifically built for health insurance. Then AlphaSense. This is a AI-powered search engine for the finance industry. So what this does is it looks at Dow Jones output, looks at Reuters news, looks at internet articles, and tries to find finance-related documents and data so that you can develop a clear idea of any finance related news or any articles related to the concepts or a particular stock you must be researching. So you'll get all the news related to a particular stock, which may be an important component in developing your intelligent stock prediction algorithm. So while that is the use case, look at Alpaca. They are a trading API and they provide real-time market data. What can be real-time data? It could be like OHLC. What is opening, what is close, what is low, what is high value of every stock. And then they let the developers develop and build and trade with various types of algorithms and bots. Then you have ISD, which is an enterprise-grade AI against world's hardest challenges. Then look at a large financial services company like JP Morgan. And this is something we have come across several examples. In fact, we are talking to one of the customers where they have lots and lots of contract documents. And what they do is they want people to use NLP and ML to extract legal documents and extract important clauses and important data points from the legal documents of contracts. So why is that required? So for example, let us say you have leasing documents. In leasing documents, you may have to extract concepts like who is the lessor, who is the lessee, what is the period of lease, what is the increment lease after the lease time is over, what kind of exception conditions are there for the lease, are there any predefined, minimum requirement for the terms of lease. So these are different conditions you may want to extract from the lease contract documents. So what happens is when you combine NLP with ML, lots of useful use cases start to come up in the context of finance industry, which are very, very relevant from a legal perspective. So on that note, I just wanted to mention a very important initiative right here in India. What has happened is about 2 weeks back or about a month back, Supreme Court has opened up lots and lots of legal documents for public for making AI-based systems using all those data. The data could be judgments related data, the kind of arguments played for each data, etc. And that will give rise to of large amount of judicial and legal AI systems, whether it is for contracts, it is for commercial, or for personal or family. Different kinds of cases, you can have different kinds of legal expert systems. So let us see some interesting patterns you may want to extract from data using machine learning. When we say signal, it actually means somewhat like anomaly. For example, in a mutual fund, having a very large balance means that you're not invested it enough, you're just lying it unused. So that's a signal. Frequent bottoming is a signal for a loan product. Similarly, repetitive transmission before 5th of every month is a signal for loan refinance. Then increase in the frequency of delayed loan payments is a signal for potential default. So what these are applications of anomaly detection techniques for different use cases. In one case, you're talking about a mutual fund. In one case, you're talking about loan refinance. In one case, you're talking about potential loan default, etc. So these are different ways by which you can start to look at anomaly detection being applied in the banking industry. So this is again a practical example of one of the large NBFCs in India we were working with. They earlier had a rule-based system for credit understanding and analyzing customers. And these rules were based on looking at the different categories of payment on time, 30 days overdue, or outstanding of 90 days, etc. And based on that, they would look at all the possibilities for identifying what would be the risk of a particular kind of person whose credit you're evaluating. And then they moved from a conventional rule-based expert. In the rule-based system, it was always the financial experts, underwriters, the risk experts, they would sit down and do a manual understanding of these are the rules which could apply. And now in the domain of ML, you don't have any human intervention. What you do is you just take lots and lots of raw historical data, look at different kinds of signals, look at different kinds of input data, and do cross correlation, and then try to find and come up with some kind of a clustering followed by classification, which gives the idea of what would be a good set of indicators, which you can try to put them into the different buckets which we are looking at. And you see there is a clear separation of the different clusters when you start applying this in ML based. So you see there's a clear separation of the different classes, whereas it's not so clear when you do the same thing in here. There's a hodgepodge where there's overlap of the kind of people we're talking about. So we can really do a neat credit bucketing kind of a default scoring based on using of ML with clustering and classification kind of techniques on historical data. That's why ML-based credit risk scoring is one of the most common use cases which lot of banks, NBFCs, and financial services institutions are all working towards, so that you do not fall into the category of a high risk or a low risk, depending upon what your past historical performance has been. Fraud detection, as I said, our goal of fraud detection is always about identification of data points which do not follow usual behavior as rest of data. While we do that, we also need to understand that we want to create a scenario where we will be looking at some normal transactions, and then out of that, some abnormal transaction just comes out. So this is the classic set of examples. Increase in the frequency of delayed loan payments. Normally, you will see frequency is in some range, but suddenly you see that for some individuals, this is shot up because that is potentially an outlier compared to the other people who have been doing regular payments. So what you do in any fraud detection kind of a scenario is you may use clustering. What clustering does is it tries to form groups of people based on their payment history, etc. And do such kind of a clustering, you will typically find that there are these outliers. What does outliers mean? Outliers means it tries to create a point which is very far away from other data points. And when you have such kind of data points which are very far away from the normal points, these are candidate fraud scenarios. So the basic premise is that based on a certain distance between data points, you try to form clustering of the candidates. Then you try to come up with appropriate number of clusters so that you're able to clearly distinguish, clusters of similar data. And in doing that, you will really come across some of the clusters are absolutely rare in the sense that they have one or two elements, whereas others will have hundreds. And in such kind of a scenario, it becomes a very obvious indication. So fraud detection via ML is a very key requirement for banks. So let's say one example I gave you was the credit card expenditure. But let me give you another example. Let us say you are normally buying, traveling all over India, use your credit card. But suddenly, suppose your credit card gets a call from a request from Pakistan. You've never been to Pakistan. That's an anomaly because it is not something which is your usual place of travel. So usually what credit card companies ask you to do is they ask you to inform well in advance if you're traveling somewhere. So whenever you're trying to apply for an international card or apply for international travel, you should also inform for your bank saying that you may be potentially traveling abroad and these are the countries I may be traveling. So you may request for a certain kind of, approval for allowing international transactions so that they're not flagged as potentially anomalous transaction and be declined. Because if suppose you are some very interesting place, you have to buy something, you make sure that you use your international card rather than carrying around cash. So what you need to understand is that fraud detection is useful in several domains in the context of identifying default transactions, could be by expenditure, could be by defaulting patterns, could be by looking at travel patterns. And another example I'll give you. Let's say we have a website, which is a banking website, and the banking website is getting a lot of hits from across the globe. But then when you suddenly see that normally you get hits like something like, let's say, 10 hits per minute. But as you see through the transactions over the past few days, suddenly you see that at some points you're seeing that there are thousands of hits in 1 second. And that moment you see that there is a really anomalous access to the website, which is not like typical normal frequency, which is like 10 hits per second. It is actually a classic case of anomaly detection. So that means some attacker is trying to launch a hack attack on your website. When you have such a hack attack potentially on your website, you should be very clearly looking at all the potential examples of how you should be able to detect a denial of service attack and then that from happening in the future by putting some kind of a firewall with intrusion prevention system. What exactly is an intrusion prevention system? Intrusion prevention system is an AI ML based abnormality detection or anomaly detection pattern on the data, which will be very useful for a bank or a financial services institution. Okay, so fraud detection is that way useful. Or I'll give you another example. I can go on and on about fraud detection. Let me tell you another example. This actually happens in especially what we call as a bidding process. A lot of times, let's say there's a telecom bidding, or let's say there's a coal auction bidding. Lots of times commercial bidding happens on government entities or for auctions in some big companies, etc. So a lot of times what happens is the companies ought to make sure that the bidding is fair and it does not go to any select or few person. But let me give you an example of an unsupervised pattern which is coming up in the area of bidding. So I was talking to one of the largest, you can say, exchange or commodity exchange kind of software builders, Plum Junction. So I was talking to them and they found out that in some of the government biddings which was happening, it is appearing that every time is going to a different person. Each round when they're bidding, they're going to a different person. But they analyze the data of who is winning the bids for over the past 5 years. They came up with a surprising element that if you look at the pattern of people, they look like it is the same 5 or 6 people whom it is rotating. So then they found out a pattern known as clique. Clique detection in online bidding is a very big fraud. Clique means they are connected to each other and they have an agreement among themselves that one guy will definitely make sure that he wins rather than others will not win. But next time the other guy will win. So it's a mutual understanding between them that they will be winning the auction at any cost, independent of who's winning. It will fall within the. So that clique detection in large commercial detection is one of the big fraud detection required for such kind of a stock exchanges or commodity exchanges or such kind of auction. So imagine the kind of fraud detection applications that can be used across financial services. It's just some of the examples I've given you, but sky is the limit where you can use AI ML in fraud detection. Then, as I said, there are lots and lots of examples of customer segmentation with ML. What is customer segmentation? Identifying groups of people who have similar buying habits. So what customer segmentation helps you do is when you're trying to sell your products, you will try to have a different strategy for different segments. For example, if you're trying to go to rural kind of a segment which you've discovered, you'll try to sell them more like a RuPay card based services with simple Aadhaar based KYC and open a simple account which does not have to be heavy, which is quite asset light, like one of the neo banks which they do. Or if you are talking about a customer who is really having high income, who is supposedly an HNI, there you'll try to offer a portfolio service where you are not only managing their account, but also you're offering a portfolio management service where you take their investment and you are advising and managing their whole portfolio. So depending upon the different kinds of customers you may come across inside your target segment customers, you may want to clustering on all the data and find out what are the different segments, and for each of the segments you may have a different strategy for offering different products and services. Then another use case here is about a chatbot. Bank of America uses AI-powered chatbot named Erica for helping customers making smart decisions, suggesting them how to save, gives information on FICO or CIBIL score, which is like what our CIBIL equivalent is, taking complaints, etc. So if a company like Bank of America is using chatbots to get so many self-service works done for customers, imagine across the globe, what is the possibility? So chatbots in America is very popular. So that's what gives you the example of typical chatbot you can build, where you can do end-to-end banking processes right with chatbots powered by intelligent agents. So what this example says to you is a classic chatbot which helps customers open accounts with the bank. So what we can do is banks can use AI-powered chatbots to service the customers, to help them take smart decisions, to perform self-service for accounts, to perform self-service for like bank balance, to push suggestions on how to save money, to give info on CIBIL score, to take complaints, etc. So where you see customer chatbots being very popular in the banking context, you see there are advisory chatbots which you can help you in taking investment advices. It tells you what kind of a combinations of product plans will be best for you. So in those cases, you take a product plan which is suggested by the bot to get maximum return. So customer chatbots is very popular in context of banks and financial services today. Voice banking. This is very interesting. We're talking about banks using Alexa-like front ends in place of chatbots to give voice bots. So what voice bots can do is they can serve customers in taking different accounts, different decisions, self-service for identifying current bank balance, push suggestions on how to save money, give information on CIBIL score, take complaints, get current stock value, all that, get current balance, all that you can get by applying voice-based bot instead of a chat-based bot. So as I said in the starting, right, we can have chatbots either with text or you can have it voice. Next, let's look at specifically techniques as applied to banking, clustering. So what you can do is you can use clustering based techniques to cluster customers based on their purchasing behavior. So there is a concept called RFM profile, which is recency of transactions, monetary profile. It's called RFM metrics. Using RFM metrics and different clustering techniques like K-means hierarchical clustering, we can understand the purchase patterns of customers and use that for winning back or offering personalized service for each cluster separately. Then classification. Classification as a technique can be used for optimizing campaigning to only target potential customers who may be good chance of being a victim of the targeting, or they will not respond to targeting. So you can write a classification model to identify who can be targeted, who cannot be targeted, based on past analysis of how they have responded. Let's look at other examples of classification. Automation of classification process of a large number of documents. For example, you can have a large number of banking documents like contract, agreement, the legal agreement. Then you can bucket them into different predefined categories and develop a self-learning model where you to keep looking at whenever you get new documents, it will automatically categorize and put them into different categories or buckets as per the kind of document. Classification. You can also do sales prediction engine based on past CRM data, news feeds, email logs, etc., to predict if a particular sale will close or not. So the idea here is to get your business problem into the right ML problem. In one case, you convert it into a clustering where you wanted to group some things. In another case, you wanted to find out if the potential target customer could be winnable or not. So that becomes a discrete, right? So it's a classification. In another case, you try to look at whether a sale will close or not. You're trying to look at by analyzing past sales data and past CRM data, etc. Given all of this, all it takes for you is to make sure that you have a structured process for identifying your data, identifying your business need, and then seeing what kind of ML model will fit for your scenario, and then apply that, and then get the result and see if that is solving your purpose. Continuing on other applications, we have seen several of them, but some existing initiatives like RPA, remote robotic process automation, is already big in a lot of banks to automate some of the workflows. Can you make it further intelligent by making it based on AI/ML? Face authentication based ATMs. This is happening in a lot of banks across the globe. Ops being done by AI/ML. Ops means looking at your logs, looking at your entire data processing, the whole pipeline, how it AI/ML to make it optimal. Personalized wealth planning. As I said, there are bots which help you in planning your portfolio. Portfolio management for HNIs or for commercial guys, where they look at the risk profile of people, they try to look at their income, look at the market, and try to see what's the best. End-to-end intelligent test automation. A lot of people have software engineering life cycle as part of the IT systems in banks and financial services. They have end-to-end IT systems. So in the IT systems, there's a lot of testing which goes on. Can we use AI to help in intelligent test automation? Video-based KYC with this is again useful, especially in Corona times. Nobody wants to visit a bank. Can we help in a video-based KYC with face recognition and appropriate authentication so that we don't want to necessarily visit a bank for a particular KYC? All that is great. But once you have decided to apply AI/ML in your organization, what is the process? That's what this slide tells you. This is a process called as CRISP DM, Cross-Reference Industry Standard Process for Data Mining. So what it tells you is understand the business first. What is the business application? Then from the business understanding, you look at, is it going to be solved using a data-based approach? Can we solve the problem by bringing data into the decision making? If yes, let's adopt AI/ML. Once you do that, then you start to look at what is the data that's applicable. Let's say you want to look at, you launched a new product in the market. You want to see whether it's successful or not. So you want to look at the social media data to analyze if the product is successful or the sentiment displayed for the product is negative. So what do you need? You need to get all the data. You have to acquire the data. You have to write scripts to acquire a lot of metadata, a lot of blog data. Then you have to prepare, means you have to clean it. When you say cleaning, it's about removing unwanted text, removing unwanted data which is not of use for you. Then modeling. Modeling is where you try to look at what kind of a problem is it. Is it a clustering problem? Is it a classification problem? Is it a clustering followed by classification problem? Is it a deep learning first, then doing a classification problem? So like that, you looked at all those techniques, right? You look at which combination is going to be helpful for you. And once you have that kind of a model problem formulation in place, you then try out different algorithms. If you do clustering, I told you there's k-means clustering, there's hierarchical clustering. You try different combinations. K can be varied. Which one looks the best? By doing an evaluation, by looking at visually. If it's a classification, you'll try different algorithms like K nearest neighbor. You'll try to look at logistic regression, or you look at decision tree, different algorithms, and see which one gives the best metrics in terms of accuracy, etc. And in fact, one thing which I don't agree with this particular slide is the fact that you also need to have a proper feedback loop here also. Because it's not like you only do modeling once, like it's a k-means problem or something. You have to try k-means with one k, then evaluate. Again, go back, try different k, try different types for the algorithm, try different variation. And then only when you're finally sure that you got a high accuracy model or a nice representation of clusters or a reasonably good error metric in regression. So that's when you say that, okay, I'll go ahead and deploy. So this feedback loop is very important. So the modeling and evaluation, depending upon how you go ahead and build your actual problem and how you're going to deploy different algorithms for the same thing, how you're going to iterate across different hyperparameters by looking at output of each time with different accuracies, etc., then you'll see the one which has the best accuracy and you'll go and deploy in the field. So that's basically what you need to do when you go and find a highly accurate model, you go and deploy. Once you deploy, it's again has to be right environment. You have to look at performance. How many people are going to have access to it? Is it going to be purely a one-time deployment, or you have to constantly upgrade? And one point which I also want to mention is you may have solved the problem for today, but suppose people are asking more and more queries which are not handled by a current chatbot. Then you have to go back to the drawing board and start with new, fresh data, fresh check business problem, fresh business data, and then go through the whole cycle again. Because most of the time, machine learning is a batch process which works with the whole life cycle being executed from one side to the other, from one end to the other, from the business formulation right all the way to deployment. So if you have to do it again after some time because your queries are not getting answered, so you got to go back and redo the data and the whole life cycle again. So it's a batch process. So as you can see, ML-based application building is not just about knowing ML algorithms. That is just 1/10 of the whole process. There's a whole, and in terms of the effort, this cycle, right, the whole cycle has till data preparation is about 90%. Data understanding, business understanding, and data preparation, data acquisition. That is 90% of the effort. The modeling algorithms, all the machine learning and all is only 10% or 5% of the overall data, of the overall life cycle. So pay a lot of attention to the data, understand the data, analyze the data, clean the data. So you make sure that you have acquisition scripts right to acquire data regularly. So that is where 80 to 90% of the effort should be. What model to create, what classification algorithm to use, that is only 5 to 10. So while a lot of institutes, a lot of academics, people talk about machine learning algorithms and all, but in the industry, that's the least important thing which you should worry about. The most important part is the data cleaning, data understanding, correcting it to the business, understanding the business, how data-driven business decision-making works. That becomes the sword. So with that, just wanted to tell you that we have a channel called Tara AI. It's where we have lots and lots of videos where we keep educating people. And I really request you to look at subscribing to this. So I'm just going to put that in the chat. Oh, there's no chat. It's only available to team members. Okay. But what you can do is you can search for Tara AI. There are 2 channels. You can go and subscribe there. So this is where we have a lot of self-explaining videos on different domains of AI, etc. I will share that with you. I will send it to you and you can just... So hope to look forward to everybody on that channel. So that goal is we spend a lot of time and energy on creating this. So parting thought, illiterate of 21st century will not be those who cannot read and write, but those who cannot learn, unlearn, and relay. Alvin Toffler. So it's time for questions. We have lost 10 minutes. Any questions? Because I cannot see the chat. So if any of you can see the chat, or you can speak, I think that should be okay.
I guess the silence means there are no questions. There's
Go
one
ahead.
question from my end specifically. So, like sir, in fintech, although there are a lot of applications where we are looking towards the customers, but at the same time, there are several efforts that tend to optimize the cost in terms of, let's say, predicting market behaviors, or maybe, let's say, predicting customer churn or things like that. So, since there are a lot of factors that can influence such decisions, how good are actually such models in, like, or how accurate they are in modeling such behavior? That is like my question.
So again, as I said, it is all a function of how much data you have. I won't want to risk an answer without knowing a specific context where you. So there are scenarios where we've gone to customers. They said, "Oh, I want to build a customer churn prediction," but they don't have more than 3 months data. In 3 months, how much people have churned? It is very small amount of data to do any kind of analysis. So you should, as I said, my goal is to tell you 80% of the data is about data understanding, data preparation, and data acquisition. If you don't have enough data, don't do AI. There's no point in doing AI for AI's sake. Absolutely no need.
There's one more question from Mr. Deepak. He's asking, sir, can you please elaborate on the fact that econometric models in prediction and applications in AI are still found to be random walk? So I am not sure that if this question makes sense. Mr. Deepak, can you like unmute yourselves and explain what you're trying to ask?
Okay.
Yeah. Can you hear me?
Yes.
Yeah. Hello, sir. My question was in the recent times using AI, a lot of financial product recommendations have been done, and at the same time, many of them concentrate on these time series forecasting models also.
Correct.
And we know that the basis for all these financial models are econometric models, which are still not so perfected. So, if this is the case, how would you go about with AI models, wherein the parameters that you consider keeps on changing? Because
Yeah.
economic
So
conditions can change,
correct.
political
Correct.
conditions can change. So, how
Correct.
would the products adopt to these changes and
So
make recommendations to?
correct. So
Yeah.
what I suggest is this. Anyone who says they want to use AIML in such kind of a dynamic scenarios with a static model build once and forget, they are wrong. You have to take into account the fact that they have to be constantly upgraded, maybe not daily or weekly, maybe. But important thing is all of these AI models, the duration when they have to be realized and refitted depends on the domain. So in a domain like insurance, where policies and all change like once in 2-3 years, you may do it every 2 years or 1 year. In a domain like retail, you do it every quarter because fashion trends change or patterns of consumption takes every quarter. In case of stock market and this kind of scenarios where you have economic models and conventional, um, typical time series models, etc. We trying to see that it should be done probably on a weekly basis. Not be like every month, but at least weekly. In case of weather, we look at every hour. So nobody, I would say, should be happy with the process that I've done this whole cycle once done. This is a constant revisiting because the underlying truth keeps changing. That's what is known as the phenomenon of concept drift. And redoing the cycle for concept drift is a fact of life. So anyone who says that I built a model, then it's going to work, that's not going to be happen. So what you said is perfect. And it's an anomaly if somebody says that I have built a static model, which will be enough for you to do this. But you have to constantly redo, depending on the patterns keep changing.
Thank you, sir. And another question. Hello.
Go ahead. Yeah, go ahead.
Can you hear me?
Yes.
Yeah. Specifically, when we look at these not so static models, also when we adopt these unsupervised learning methods, specifically clustering for recommendation purposes, also depending upon the distance measures also that we take, the recommendations keep on changing. So the financial product which was supposed to be recommended last week is found to be not so suitable in the next week.
So I was not saying about the refitting only applicable for classification or regression. It can also be applied for unsupervised machine learning also. Wherever there is data, underlying data keeps changing. See, what is ultimately ML or AI? It is about bringing the pattern that is there inside the data out, right? So the pattern is changing. What you discovered as a pattern sometime back, and the pattern underlying has changed. So you have to do that. Whether it is distance metric has changed or whether it is the underlying stock pattern has changed, doesn't matter. So the concept drift applies to unsupervised as well as supervised.
There's one more question. Sir, there's one more question. I think that will be the last question for the session. So the question is from Dr. K. Swarna, and she's asking that how can we predict whether at some place fraud is taking place? So, any web-based fraud that is interested.
It purely depends on what kind of. It's a very generic question. So unless I know the specific
Type of
problem you're looking at, if you're looking at web access and seeing if there's some fraud happening on the access, you can look at the logs and do the anomaly detection. If it's about transaction location, you can find out, like I told you. If it's about consumption behavior change, so it's all about what data are you bringing out anomaly about. Like this generic question is difficult, but it depends on the particular domain, particular action, particular data on which you're trying to find anomaly.
Sir, thank you, sir. So now we do not have any more questions. So I guess it is now my time to thank you on the part of the whole organizing team and Department of Computer Science and Engineering for joining us today, sir, and for sharing your knowledge, wisdom, and experience with all of us. We are really grateful to you for accepting our request.
Okay, thank you. Thanks a lot for the opportunity. And I'll send my channel link. Please transmit all.
Definitely, definitely.
Yeah. Thank you.
Participants, we'll be starting our course and quiz in like 5 minutes. We'll take a 5 minutes break and we'll start the course and quiz sharp at 3:05. Okay, and also the attendance link for this session will be shared after the quiz. So while the quiz will be online, I'll share the link. So as and when you complete the quiz, you can attempt the attendance feedback from this. So first we'll be starting.
Same link.
Yes, ma'am.
Link is same. Link will be the same
I'll be
we are
sending
there.
I'll be sending the link on WhatsApp as well as MS Teams.
Thank you.
starting it at 305.
Okay.